Today's video is going to be about the properties of a rectangle and square, and then how to use the properties to find the missing measures in the rectangle or the square. So to get started, let's review the properties. For the rectangle, it has all the properties of the parallelogram. And it also has properties where all angles are equal, all angles are congruent, and then the diagonals are congruent. For a square, it has all properties of a parallelogram, a rhombus, and a rectangle. So the square is going to have all the properties, all 5 from the parallelogram, the 3 from the rhombus, and the additional 2 from the rectangle. So we're going to start with our rectangle. So I'm going to start by marking on my picture, opposite sides congruent. And I know my diagonals are congruent and they're being bisected. So these 4 pieces here are all equal. So I'm going to start by solving for A. So I'm going to say 3A is equal to A plus 8. And solve, so I get 2A equals 8. So A is going to equal 4. Using that property that the diagonals are congruent and that the diagonals bisect each other. Those 2 properties. And then I'm going to look at my sides, which is x squared plus 7 and then the 9x minus 7. Opposite sides are congruent. That's a property of a parallelogram. And I'm going to go ahead and set those equal to each other. This problem is going to include factoring since I do have an x squared. So I'm going to move the 9x and the 7 over. So I can get everything on one side. So x squared minus 9x plus 14 is equal to 0. So I need factors of 14. So I'm going to use 2 and 7. So I've got x, and then I'm going to use 2 and 7. So to check, I'm going to multiply here and multiply here. The only way to get a negative 9 is with a negative 2 and a negative 7. So these are both going to be subtraction. So I get x minus 2 is equal to 0 and x minus 7 equal to 0. So this is x equals 2 and x equals 7. So I have 2 answers for that one, which is okay since it's not the side length. We're just going to take both answers. Okay, now we're going to move on to our rectangle again, but now we're given different measurements of it. We're going to find all of the angles and all of the sides. So it's telling us that DQ is equal to 9, and AQU, this angle 6 right here, is 60 degrees. So I'm going to go ahead and just use that 60 degrees. So I'm going to go ahead and go through and fill in all of the missing information on here. So I know a rectangle, all 4 angles is 90 degrees. So I know that this angle is going to be 30 degrees. I know that this is going to be 60 and 30, 30 and 60, 60 and 30. I know that those are all going to be split up the same way. And then to find angle 4, I can look at this triangle QPU. Angle Q up here is 60 and angle U is 60. So that means this angle is going to be 60 and 60 vertical angles. And then to find angle 1, I know that angle 1 and 4 would be supplementary. So 180 minus 60 would be 120. And this would also be 120. So now that I've gotten all my angles, I can find my sides. So I know that UA is also 9 since opposite sides are congruent. I'm going to go ahead and switch colors so you can see. And then I'm going to use this 30, 60, 90 triangle right here to find my other missing pieces. So I'm going to find the length of DA next. So you can see my picture would look like this with a 30. This is Q, D, and A. And this is 9. And I want to find the other 2 pieces. So I'm going to find DA first. So I have the side opposite the 60. So to go backwards, we're going to divide by the square root of 3 using our 30, 60, 90 rules. And then we're going to rationalize the denominator. So I get 9 root 3 over 3, and this 9 and 3 make a 3 root 3. So DA is 3 root 3. And then I'm going to double that, which would make 6 root 3 for the length of QA. but I know that QA is being bisected. So I know that QP is 3 root 3 and AP is 3 root 3. You can also see this 30, 60, 90 triangle here with P, D, and A. So I know this is 3 root 3 and this is 3 root 3. And then opposite sides congruent. So I filled in all of the sides and all of the angles of the rectangle and I was only given one side length and one angle measure. On the next one, we're going to use properties of a square. So I know in a square that all 4 sides are equal. I know that these angles are being bisected here. And I know that I have perpendicular bisectors here. So I'm going to set 15x equal to 90 and then divide. So I get x equals 6. And then to solve for y, this 90-degree angle is being bisected, so half of 90 is 45. So I'm going to say 5y minus 6 is equal to 45. And solve. Divide by 5. And I'm just going to have a fractional answer for this one. So I've used some different properties, angles bisected by diagonals. And then for this one, we use that the diagonals were perpendicular bisectors. Okay, we're going to do one last example where we're only given one length, and we're going to find all of the remaining pieces. So I'm going to switch to blue here. It says that AB is 22. Well, I know that all 4 sides are equal, so I'm going to go ahead and fill that in. I know that all the angles were 90. And then they're being bisected. So this is actually 45, 45, all the way around. And I'm just going to go ahead and mark all of them. I know that the diagonals are perpendicular bisectors, so I'm going to mark 90 degrees there. And then to find the side lengths, I'm going to use this 45, 45, 90 right triangle to find my other pieces. So I'm using that triangle ACD, and this is ACD. It looks like this with 22, 22, and this is a 45, 45, 90. So since both legs are 22, I know the hypotenuse is going to be 22 root 2, so AD. But I also know that the diagonal is being bisected, so instead of 22 root 2, this is actually 11 root 2 and 11 root 2, along with EB and EC. So although I was only given one piece of information, I used all my properties of a parallelogram, a rectangle, and a rhombus to find out all the missing pieces for this square.